Hey guys, BuildZoid here, and welcome to the 17th weekly HWbot score roundup, and we got so many scores to get through. Like, I don't know what it is, but it's like everybody decided, it's like everybody got their liquid nitrogen delivered in the same week. And so, yeah, here we are with a loss of scores. So, let's just get right into it, or this video is just going to go on forever. So starting off with safe disks, 12-core HWbot X265 benchmark 4K top score. So this is 4K video encoding using X265 on a Ryzen 9 5900X at just over 6 gigahertz, producing 41.118 FPS. And taking the record for X265 on a 12-core CPU. And yeah, so Safe Disk is works at Asus ROG, so he's running a Crosshair 8 Extreme, which is not yet released. We can see we have 4 memory sticks in there, so that's a dual rank memory configuration, isn't it? Yep, that's dual rank. If it was 64 gigs, then, you know, that'd be quad rank, but I don't think the memory controller would be too thrilled about that, especially on liquid nitrogen. I'm assuming this is in 1-to-1 mode on the memory controller, because I believe X265 actually prefers that instead of like 2-to-1 mode. Memory is running 3800, 14, 14, 14, 28. And, well, the Infinity Fabric should also be at 1900 megahertz. And then the CPU is just over, like a little over 6 gigahertz, which I believe is the highest clocked 5900X, though it might be per CCX. So one of the CCXs might be, or, well, yeah, one of the CCXs might be clocked a bit lower, or a bit higher, actually, considering that Splave has a higher. Actually, do we have a CPU-Z? Oh, we don't have CPU-Z links. Oh well, that's a shame. Because like the thing is, you can do per core, like per CCX overclocking on the 5900Xs, and I guess then most of the difference here is. Actually, I don't know where the difference comes from. Like, this is dual rank. Wait a minute. Is this? So this might actually be a CPU that does 1-to-1 versus a CPU that does 2-to-1. And that might be where the difference is coming from. Unless... Yeah, I'm assuming that's what's doing this. Because Splave is clocked slightly higher on the CPU. Safe Disk is, you know, his CPU is clocked slightly lower, but if his Infinity Fabric is actually capable of running 1900 on liquid nitrogen, then whereas Splave's is doing, well, we don't know if Splave is running 2-to-1, then I'm surprised he's not running the memory faster. But well, in dual rank, the memory controller doesn't really go much past 3800 anyway, so that doesn't really, it's probably not helping. Yeah, so I'm assuming it has to just come down to the Infinity Fabric clock, which is very hard to get, like, high Infinity Fabric clocks on liquid nitrogen with Ryzen. Basically, the only Ryzen generation that behaves well on liquid nitrogen is the 2000 series. Everything else is just, like, well, 1000 series is horrible. 3000 and 5000 series are very fiddly. And very difficult, like, especially if you want high Infinity Fabric clock, that is very hard to do. And yeah, so we've got G.Skill Ripjaw's 5 memory, which, you know, Samsung B-Die, you can tell because it's 3800, 14, 14. Like, the CL14 isn't the big deal. The big deal is the TRCD14. You don't do TRCD14 at 3800 on, well, any other ICs that, like, other than, like, Samsung B-Die, so that's what's going on there. And yeah, a very impressive score from Safe Disk here for the 5900X. So yeah, congratulations to him on the world record in 12-core HWbot X265 4K. And let's move on to the next score, because there is a lot of them, which is not this, it's this right here, which is Senz's Geekbench 3 multi-core, actually 8-core wait, is this? Oh, whoa. So yeah, Sen's managed to get the 8-core Geekbench 3 multi-core world record on the 11900K at 6.733 gigahertz. So that chip is absolutely flying. Now, funnily enough, compared to 10th gen chips, which that's going to be actually really awkward to switch it over to 10th gen. Because the thing is, 10th gen CPUs actually outclock the 11th gen CPUs, but of course 11th gen has more IPC. So actually, if we drop down to Intel, yeah, so you have like 9900Ks doing over 7 gigahertz for Geekbench, but of course scoring lower because of the IPC advantage that Rocket Lake has, which only really is applicable to synthetic benchmarks. Because for a lot of other things, Rocket Lake does actually end up just being slower than, well, like Coffee Lake 8-core CPUs, depending on what exactly you're doing. But yeah, Geekbench, just doesn't really care about real-world performance that much, and so it loves 11th gen CPUs. So yeah, 6.7 gigahertz on the CPU, which is very high for an 11th gen chip. And then the memory doing 50, that's like 5333, that's over 5333, that's like 5380? No, 5360. Yeah, so 5360, 15, 15, 15, 28. So the memory bandwidth here has to be absolutely insane. And of course, Geekbench absolutely loves that because Geekbench loves memory bandwidth. That's like basically what the Geekbench memory test is, like the multi-core memory test is just like how much memory bandwidth do you have? And the more memory bandwidth you have, the bigger your memory the bigger your memory subtest score is going to be. It does scale a bit with dual rank, but not enough that you would be able to like catch up to insanely clocked single rank configurations like we have here, which the Z590 Dark is very, very good for single rank BDI overclocking. Like, yeah, this board is just like there are other boards that can do comparable memory settings, but not many. Okay, like doing these kinds of memory clocks is very hard. And you do need a very good CPU with like a great memory controller and then also really good memory sticks. And apparently, I wonder if they're actually sub-zero or if they're just like being mildly temperature controlled, because BDI tends to have like a temperature sweet spot where it runs best, and then at any other temperature it just gets worse. And that, well, I guess it might also be the end of the session, so hard to say for sure what's going on with the memory. I think I have seen like some people have been running like cold BDI for the Geekbench runs where it's actually sub-zero. But this kind of looks like maybe this kit just needs to be like approaching zero instead of actually below it. Yeah, and then of course G-Skill Samsung BDI kit. And yeah, and the Z590 Dark, lapped CPU. I'm assuming the LN2 pod is also lapped. KPX thermal paste on there. So yeah, just a very, very, like an insane memory overclock, a very good CPU overclock as well. High on-core frequency at almost 6.5 gigahertz. Let's compare against the next score down, right? Like it's always worth checking. So, man, why does SafeDisk have to use a 4K monitor? Okay, nope, that's not what I wanted. Open link. There we go. Actually, no, this is probably 1440p. Yeah, no, if it was 4K, this would be so much worse. This is 1440p. So yeah, Sens seems to mostly have an uncore clock advantage. There's also a little bit like, slightly higher memory clock. Significantly higher actual like uncore clock. So that's the actual like cache clock, which would help the memory test, but also even just the CPU tests themselves would gain from that, which we kind of see. Yeah, because the floating point test is a little bit higher for Sens than for SafeDisk. Then single core is actually slightly better for SafeDisk. It's a very small margin by which Sens has taken the top score. It's literally 1 point. So yeah, that memory, like the slightly higher memory overclock and the better cache overclock, like that's basically what made this score, because Yeah, it's not the CPU clock here. Like 6.7 gigahertz is very high for an 11th gen, but you know, SafeDisk is doing 6.806, like 6.806. So SafeDisk does have a CPU clock advantage, but in terms of the actual like cache and memory performance, Sens has the advantage there, and that's enough to eke out the win for 8-core Geekbench 3 for now. I can't imagine that like SafeDisk won't be responding to this, though. At this point, we might see them just wait. Well, I don't. I guess it depends how busy they are with Z690. Because at this point, I'd be like, you know, we might see them just wait for Z690 to launch for the next round of Geekbench 3 records, but that's still a while away. So maybe we'll see some even higher 11900K scores before that, and then also we might not actually see a new 8-core CPU. So, yeah, but. Anyway, so yeah, congratulations to Sens on the Encore and memory overclock, and the first place in 8-core Geekbench 3 with the 11900K on the Z590 Dark. Next, we have Splav's quad-core GPU Pi for CPU. We've seen this in the recent roundups over and over and over again. The 5300G is very good at GPU Pi for CPU 1 billion. It's currently the best CPU for it. And so Splav previously, well, White Shark beat Splav. So White Shark was second place like last week. And Splav has now beaten White Shark by like slightly less than a second to reclaim second place in GPU Pi for CPU, with the 5300G now at 5.55 gigahertz, and the memory doing 4800, 1414, 1448, which of course, so. Did he change motherboards? No, it's the X570 Aqua again. So Splav is supported by ASRock. He doesn't work as far as I know, he doesn't work at ASRock, but he is supported by ASRock in terms of motherboards. I guess GPUs as well, though. Well, ASRock doesn't make 3090s, so you know that makes it kind of awkward. But yeah, so just, you know, a very high clock for the 5300G there, and then the thing is the AMD APUs, their memory controller is really good. And it plays really great with Samsung B-Die just in general. So 4800, 14, 14, 14 on a 5300G is actually not that surprising. That's kind of like, yeah, you know, like this is easier to do on an AMD APU than many other kinds of CPUs, but even then it like still requires a very good very good kits of memory and a solid motherboard. Not all motherboards are going to do this even if you do use an APU with them. And yeah, and then GPU Pi though is primarily about CPU clock speed. Not that the memory is completely irrelevant, but like the main thing that determines how high your score is going to be is the CPU clock, right? Like White Shark was clocked slightly lower, with slower memory, but you know, in terms of the actual performance gap in the scores, like it's not that much. And Splav has a very slight CPU frequency advantage, and so Splav has now retaken second place for GPU Pi for CPU. And SafeDisk is still very safe in first place. So, yeah, congratulations to Splav on the second place score with the 5300G in GPU Pi for CPU 1 billion. And let's move on to the next score. And now we get a score that, like, I am very impressed by this, mostly because I don't understand how this works. So, Bull Ant has taken the world record for single GPU 3D Mark 2001. Actually, just straight up world record for 3D Mark 2001. Because the funny thing about a lot of these really old 3D benchmarks is that they're basically CPU benchmarks. And so the overhead of having more than one GPU just basically makes it impossible to take the world record. So you really, like, you get the world record with a single GPU setup. So outright world record for 3D Mark 2001. SE, using a GTX 980 and of course the 11900K, because Well, like I said, this is basically a CPU benchmark at this point. And the 11900K's crazy high IPC is actually very, very good at 3D Mark 2001. Now, 3D Mark 2001 is sold that I do believe this is Windows XP that we're looking at here. And that is a sort of funny thing about a lot of the extreme overclocking focused Z590 boards is that they have dedicated SATA controllers specifically for Windows XP support because the like stock chipset, the Z590 chipset SATA ports, yeah, Windows XP just doesn't understand how to use those. So Bull Ant here is using the Gigabyte Z590 Aorus Tachyon, which does have a set of SATA ports that are compatible with Windows XP. The Z590 Dark also does that. I think the Apex also does that. I'd be surprised. I'm assuming the OC formula from ASRock also has that. Like, it would be really weird for the OC formula not to have that, because it's really, like, it's just a matter of getting there's like an AS Media SATA controller that just, you put on the board, bam, you've got Windows XP support. The alternative is to get like a SATA, like a PCIe to SATA card that does that, but, you know, why would you do that with a 4-DIMM motherboard? So, anyway, yeah, so Z590 Aorus Tachyon, CPU doing 6.8 gigahertz on just 5 cores and 5 threads, because this benchmark is very old. If you give it too many cores, it gets very confused. 5 cores is actually kind of a lot of cores. I guess it's 4 cores for the benchmark and then 1 core for the OS, or we're looking at some kind of weird like per core overclock. Also, 184, is that glitched out? That's got to be glitched. That might actually be real. 1 to 12. Okay, wait a minute. I am very confused. We need a calculator. So 4400 divided by, so that's on the 24 times ratio. Oh man. Oh, I guess it really is 184 BCLK. That is super weird. Why would you do that? Like, there's nothing inherently wrong with doing like super high BC. Is it to overclock the PCIe or something? Like, I am very confused as to why you, like, the thing is, so with Skylake, Intel actually decoupled their BCLK from the rest of the basically the rest of the platform. So say if you were overclocking a Haswell or like a Sandy Bridge CPU, if you push the BCLK, it overclocks like your PCIe and it overclocks your SATA ports and it overclocks everything. And eventually something gets very upset about any BCLK overclock. And so on, you know, those older platforms like Haswell, Sandy Bridge, Ivy Bridge, if you ran like more than say 107 BCLK, well, even 107 BCLK was already very difficult to do a lot of the time. But with Skylake, Intel basically went like, okay, we're just going to separate the BCLK from the rest of the platform. And so now you can run basically whatever BCLK you want. There is a upper boundary, but it's very, very high. And so that's kind of what we're seeing here, right? With that 184 megahertz BCLK. I'm still not certain that that isn't bugged out, because like, why would you? Because like, it is doable. Like, this is fine. There's nothing inherently wrong with like the platform supports this. You can do this. It's fine. Like, yeah, the hardware can do this. The question what I don't get is like, why would you do that? Is there some weird like memory training relationship between the memory ratio and so like at high memory ratios, the memory controller doesn't do what it like doesn't train properly, so you have to run like a low memory ratio with really high BCLK to get it to work. But this is in gear 2 because the memory controller is actually underclocked, like running at half the rate of like half the speed of the memory. So yeah, I am very confused as to what is going on here. And then also this is 3D Mark 2001 SE, which is a benchmark that I don't know how to run like this is one of those benchmarks where it's really like a tweak fest. There's a whole bunch of things you can do to make it run better. I don't know what any of them are. I am not good at these kinds of benchmarks. I basically avoid them to the best of my ability. but an extremely impressive score. Like, this is literally the 3D Mark 2001 SE world record, you know, on a GTX 980, no less, which is kind of the cool thing about these older. Well, actually, the reason why you see 980s and like a 980 Ti and then another 980 Ti and a 780 Ti and a 980 Ti is because anything newer than that doesn't actually have Windows XP compatible GPU drivers. So while, you know, maybe a 1080 Ti would potentially render 3D Mark 2001 somewhat faster, it won't run Windows XP. That's far more important than your ability to run, like, render 3D Mark 2001 quickly. Because, yeah, if you run this on, like, a newer OS, and the benchmark will run on newer operating systems, you can run this on Windows 7. It'll just not score this high. And running it on Windows XP, as far as I know, is probably not the only thing you have to do. But yeah, so this is one of those weird old GPU benchmarks that is, though I think 2003 is the one that's like really difficult, and 2001 is just, I don't know. I don't bench these old 3D benchmarks seriously. This is a lot like me looking at LGA 775 scores and going like, that's that's a very high score from based on the ranking. I don't know how it works though. Um, but yeah, like, still a really impressive score. Like, it's literally the world record for 3D Mark 2001 SE, and this is a very popular benchmark, mostly because it's been around for ages and ages and ages. So, you know, people have been posting ever higher scores for it for ages and ages and ages. So yeah, congratulations to Bullant on the world record in 3D Mark 2001 SE, and let's move on to the next score, which is Senz's SuperPi 32 million, third place with the 11900K at 7.06 gigahertz, taking 3 minutes, 40 seconds, and 532 milliseconds to calculate 32 million digits of the number pi with a single CPU thread, because this is a single-threaded benchmark, which actually makes it like, it's kind of like one. The thing is, like, so SuperPi is a benchmark I didn't like until the 11th gen came along, because SuperPi just takes forever if you run it on older hardware. It's like if a benchmark takes more than like 5 minutes, it's not a fun benchmark in my opinion. And this is a perfect example of that. Like, on older CPUs, this easily takes 7 minutes plus, and it's just like, nope, I'm not running that. I don't have the patience for that. But with 11th gen, on liquid nitrogen, it takes under 4 minutes. And the top scores are, you know, approaching sort of the mid 3 minute mark, like 3 minutes and a half-ish mark. And so now it's a cool benchmark. And what's even cooler is with 11th gen, you can actually run it on, is this not XP, or is this just Windows 7? Windows 7, yeah. So this is just Windows 7. So you don't need to run it on Windows XP anymore. Not that, like, you would necessarily, like, the Dark does support Windows XP. It does have 2 SATA ports that will run Windows XP, so there's no reason that you wouldn't run, like, that you couldn't run it on XP, except if you're like me and you just don't really feel like installing Windows XP just for the sake of running one benchmark, which is where I'm at with this. And so the interesting thing about SuperPi is, unlike a lot of the other memory benchmarks out there, this thing is super sensitive to memory latency. It does still appreciate high memory bandwidth, but it's more skewed to, like, where Geekbench is basically just a memory bandwidth test, SuperPi isn't. And so what we have here is a single rank memory configuration, like single rank Samsung B die doing 4226 CL12, which is a thing that B die does. You do need some very good B die to hit that kind of speed at the CL12, but yeah, that's a thing that Samsung B die does. And this is running on the Z590 Dark again, because, you know, like, it's the same. That's the board that Senz is using here. Yeah, so you're gonna run this in Gear 1 and then just get the the timings as low as possible, and, you know, then push the frequency as high as possible. But you're gonna be on like CL12, TRCD12, TRP12, actual 1T command rate, because in Gear 2 you don't have a 1T command rate. It's not possible. Like, the memory controller will always be issuing, even if you set it to 1T. the memory controller is going to be issuing commands every other memory clock cycle because the memory controller is running at half the speed of the memory. So yeah, this is like a really low memory latency overclock that we're looking at here. I'm surprised he didn't try to do this with dual rank, or maybe he just doesn't have a strong enough kit of dual rank memory to like justify using it on LN2. Because that should, like, assuming that you don't lose, because at these lower, as long as you don't lose too much frequency, dual rank should actually help SuperPi, unless you get stuck at like 2T command rate, which even that might still be okay though. Anyway, and then yeah, the CPU, 7 gigahertz because it is a single core benchmark, and you run it with 3 cores and 3 threads, and I believe this is mostly because of some, like, you want one core for the OS, and then one core for the actual benchmark, and then the third core, I'm not sure why it's there, but it does make it run faster. So you do want it running 3 cores, 3 threads. Might be something to do with caches or how the CPU's laid out, but anyway, so the standard is to run it with 3 cores and 3 threads. And yeah, and then we have Benchmate, and there's a bunch of like weird software tweaks that you can do to make SuperPi run faster. And what's really impressive about this, at least to me, is that this is a top 3 SuperPi 32 million score that isn't on Windows XP, because I'm pretty sure this is Windows XP. I'm pretty sure this is Windows XP. I don't use it enough to be 100% certain on that. And this is also going to be Windows XP. So, like, now you can run SuperPi on a normal OS. Even Windows 10 isn't too bad, but obviously 7 is going to be a little bit faster. And then Windows XP is probably, like, should be the best if you have it properly set up. So yeah, still a really, really great score from Sens here. Pushing the 11900K to just over. Well, actually, that's not just over. That's almost 7.1 gigahertz, right? Like, it's past the halfway mark. You round up. So yeah, clocked insanely high, like very high CPU clock, very low memory, very low latency memory settings. Actually, I just wanted to check if the dual rank thing is a thing. Oh, we won't know because this is on Windows XP, and so they have maximum set to 600 megabytes. This one also, isn't it? Oh no, and this is single rank. So maybe single... Oh, and this is like 1110 at 3800. Interesting. I want to mess with dual rank for this. Because, like, the thing is, dual rank at high frequencies tends to be a problem because you lose a lot of frequency for that extra memory rank. But at low frequencies, it shouldn't really hurt anywhere near as much. So, yeah, like, because I do plan to, like, I really want to mess around with SuperPi 32 million on my 11900K pretty soon as well. I've already done some, but I want to do more with liquid nitrogen on it. And so... Oh well, we'll see where I end up. If it turns out maybe dual rank is just a bad idea, and I'll end up in like, I don't know where I'll end up, but it is something I want to experiment with because theoretically it should be a bit faster. Because in the DDR3 era, the norm was to run dual rank. Like, you just always ran dual rank because DDR3 didn't clock high enough to justify using single rank DIMMs. But with DDR4, the clocks are so high that dual rank regularly, like the signal, like the effect the second memory rank has on the ability, like on the clocks you can run, is just so great compared to what it did on DDR3 that, yeah, dual rank's not really cool for a lot of the like extreme overclocking benchmarks. But yeah, anyway, still a very impressive score. Third place in SuperPi 32 million. This is a very difficult benchmark, just by the way. Like, very old benchmark, very popular benchmark, very difficult benchmark. Because, it takes a while, and you do need to, like, really dial in your memory settings. And your OS to some extent as well. Less so than it used to be, but even now, it's like, you do still, like... Yeah, like you do still need to like work on your software level efficiency for this benchmark. So yeah, great score from Sens. Congratulations to him on that. And let's move on to the next score, which is not this. But this right here, which is Ovis Hardware Labs 3D triple GPU 3D Mark Time Spy Extreme record. So yeah, well, top score, and this is with 3 GTX 1080 Ti's, and this right here is why I'm sort of hoarding GTX 1080 Ti's. I have 3 of them at this point. Is basically because of things like this right here, where it's like GTX 1080 Ti's are the last GPUs to support triple SLI and as well as quad SLI, and HWbot has a lot of benchmark categories, which are, you know, things like, well, basically all the 3D benchmarks are split up by single GPU, dual GPU, triple GPU, and quad GPU. And so 1080 Ti's are the only GPUs that are still eligible, that are going to be eligible for triple and quad GPU unless Intel decides to bring quad GPU back or something, which is very unlikely because I think the GPU industry has collectively decided that selling more GPUs to people is like more work than just selling them one really expensive GPU instead. Right? Like selling somebody 4 $800 GPUs is less effective than just selling them one $3,000 GPU, which is the way it's going with the 3090 right now. It's not quite that bad, just, well, it's approaching that. It's certainly approaching that, isn't it? But yeah, so cool score. I love big multi-GPU setups. Unfortunately, we can't actually see this big multi-GPU setup because there's no picture of it. Also with a 3990X. So this is like the one benchmark where running a Threadripper 3990X that like isn't a CPU benchmark makes sense, because the Threadrippers are actually general, like when you look at the, I wonder if we have a good comparison point for that. Though I think the other people might have run 3990Xs as well. Oh no, that's X299. And also Time Spy Extreme probably is so heavy on the GPU that it doesn't really make too much of a difference. Yeah, which certainly seems to be... Wait, we don't have a valid link on that? Really? That's not... No, that's the wrong motherboard. No verification links on any of these. Well, that's fine. Oh, that's a shame, because I wanted to see like the average clock readout from 3D Mark. But yeah, so little over 2 gigahertz on the 1080 Ti's, which for 3 of them is reasonably like that's pretty impressive. Not all 1080 Ti's will go over 2 gigahertz, even if they are on water cooling. And this got to be quite... Actually, this is chilled, so I guess that's 2 different water loops. So one ambient loop for the GPUs, and then a chiller for the actual CPU. And 4.55 gigahertz on that Threadripper that's intense. Time Spy Extreme, I'm assuming is very, very power hungry on the CPU. Because even regular Time Spy, like the regular Time Spy CPU test is actually quite heavy compared to some of the other 3D benchmark, like other 3D Mark CPU tests. It is quite heavy. So I've never run Time Spy Extreme myself because I don't have a 3990X, so, which is a really big part of this score right here, is just like, yeah, because the CPU test in this is designed to go up to like absolutely insane core counts. So this benchmark is truly extreme. Like you need a ridiculous, GPU setup, and then also a ridiculous CPU to go with it. Unfortunately, the 3990X is not competitive in basically any other benchmarks, which does kind of make it for like 3D. By that I meant like GPU benchmarks. Of course, it's great for like 64-core Cinebench and that kind of thing, but for 3D benchmarks like Time Spy, it's like, well, you wouldn't run it for regular Time Spy because regular Time Spy doesn't go above 16 threads. And then you have Firestrike, which doesn't go above 32 threads, or 3D Mark Vantage, which doesn't go above 16 threads, or 3D Mark 11, which doesn't go above 32 threads, or you have Port Royal, which doesn't use the CPU at all, so you may as well run it on like an i5 for all Port Royal cares. So that's kind of the thing, is like this is sort of the one benchmark where one GPU benchmark where the 3990X is actually useful. And then also it helps that it has enough PCIe lanes to actually connect to all of those GPUs and enable SLI. Because that, like the thing is it would be really cool if you could run like for a lot of other benchmarks, it would be really cool to run quad SLI on like a 5950X, except you can't because you don't have enough PCIe lanes to do that. But of course, that's not an issue for any of the Threadrippers. The only issue with them is that they're not very competitive in the other benchmarks, whereas for like Firestrike, you would actually just prefer to have a 5950X basically always. And we might see that change with the 5000 series Threadrippers, but still, yeah, this is a really just well, it's an extreme score, right? Like a huge multi-GPU setup, massive CPU overclock. Like that thing's got to pull so much power. That's 64 cores. Also, this is an AVX accelerated benchmark. Like the CPU test here uses AVX instructions, so it gets quite hot. Yeah, and then the 1080 Ti is doing a little over 2 gigahertz each. So yeah, an impressive score from Ova's hardware lab here for 3D Mark Time Spy Extreme. Congratulations to him or them on that. I wish we had system pics. Like, I really, really want to see what this monstrosity looks like, because this is a monstrosity. There's a chiller on one of the CPU. So, yeah, anyway, let's move on to the next score, which is Dark Gregor's Y-Cruncher Pi 1 billion, second place on the Core i5-11600K. So, last week we featured and I'm going to call him Anthony. Somebody said in the comments under the last video, under the last roundup, that's not how you pronounce it. I don't know how else to read that. It's French, literally. So, there. But yeah, so Dark Gregor has now taken second place with an 11600K in Y-Cruncher. And this is I've said basically everything that's interesting about this in the last roundup, but the thing is, Y-Cruncher is super memory bottlenecked. But with 6-core CPUs, it's just it seems to be, and especially what an advantage that 11th gen chips have is that they have a lot of IPC and they have AVX 512 support. So 11600Ks are actually very competitive in this. 11900Ks aren't, because 11900Ks have to compete with 7820Xs, 9820Xs, and 8-core X299 CPUs. And 8-core X299 CPUs have quad-channel memory controllers. So the 11900K with its dual-channel memory controller just doesn't have enough memory bandwidth to feed 8 cores doing AVX 512 instructions. The 11600K, however, is in an interesting situation where it's just small enough that its dual-channel memory controller doesn't run out of bandwidth before the cores before the cores max out. So, here we have the 11600K at just over 5 gigahertz, hitting 100 degrees Celsius because Y-Cruncher is AVX 512. And if you, run a dual rank memory configuration with tight timings like this, it's going to pull absolutely ludicrous amounts of power. This makes everything else just look like an absolute joke in terms of power consumption. I mean, it's like LinPack, basically. And LinPack has the same thing where heat gets hotter and hotter the more the better your memory overclock is. And also Y-Cruncher, like LinPack, is very sensitive to overall system stability, so you can't really get away with the kinds of overclocks that'll run Geekbench or something like that. And so that makes it it's a benchmark I'm a big fan of, because this is probably the only benchmark that gives you a realistic idea of what would actually be stable for long-term operation. Now, obviously, it only lasts 33 seconds, so it's not really a stress test, but it's a lot more of a stress test than Cinebench is, which basically, Cinebench basically doesn't use the CPU's memory controller, whereas Y-Cruncher pretty much sets every every millimeter of your CPU that's actual CPU and not iGPU. Yeah, sets it on fire. So that makes it a really just ridiculously intense CPU benchmark, and I'm a huge fan of it because of that. Because it's it loves memory performance. It does somewhat scale with CPU clocks. The funny thing is, like, if you have bad memory settings, you can actually run really high CPU clocks for Y-Cruncher because it just stalls out waiting for memory access. And so, the CPU is basically sitting there twiddling its thumbs waiting for data to show up. And that's why, here Dark Gregor is running dual rank. What is that? That's like 4533. Actually, that's 4546 CL15. With the Uncore doing 4.5 gigahertz, because like the Uncore is your L3 cache, which obviously connects the memory controller to the cores, so that gets slammed as well because like Y-Cruncher puts just so much data through the CPU. Because AVX5, you can kind of think of AVX512 instructions like GPU style instructions on your CPU. And if you may have noticed how GPUs run very low clocks and pull stupid amounts of power, well, that's sort of what's going on here. And so anyway, this is actually on chilled water cooling, and that 11600K is still hitting 100 degrees Celsius on load. I would love to see the power draw readout for this. Like, this was easily pulling, like, I would not be surprised if this was pulling over close to or more than 300 watts. Because Y-Cruncher is insane in terms of how much power it pulls. And this was run on a Maximus 13 Apex, G-Skill memory. Do we have an SPD? Oh, we do have an SPD. So this is a 4000 CL16 dual rank kit from G-Skill. And of course, Samsung B-Die because of the timings. And yeah, just a very impressive score in a very intense benchmark. So congratulations to Dark Gregor on that. And hopefully he'll be taking it on LN2 and beat Miller's i7-7800X. Because that's the thing is, like, the 7800X currently holds the top score for Y-Cruncher because it does have full AVX512 support, which 11th gen does also, but on a 7800X, you only need like 3800 CL12 in order to get, or actually this is 3733 CL12 to get like ludicrous amounts of memory bandwidth because it's quad channel, right? So basically per clock, this has 2 times the memory bandwidth of a dual channel CPU. Now, obviously the dual channel CPUs can clock the memory higher, but you're not twice as high. Right, like that's the thing is like, yeah, basically for a 11600K to have the same level of memory bandwidth as a 7800X, it would have to be running, like over 7 gigabits per second on the memory, which not happening. It's just not happening. Like the world record for memory overclocking, right? Like, yeah, that's basically the world record memory overclock for single channel operation, and just for the sake of saving a CPU Z screenshot, not actually being able to do anything with it. But still, a very impressive score from Dark Gregor and Y-Cruncher here, and it'll be interesting to see if the 11600K can beat the 7800X, because Miller probably has a backup with a higher CPU clock. Not necessarily better memory settings, but I would be surprised if 5 gigahertz was the limit of what he got out of that chip on LN2. Though Y-Cruncher is very hot, so even on LN2 you don't really get to clock the CPUs that high. Just because of how, it's a crazy benchmark. So anyway, congratulations to Dark Gregor on this score. Let's move on to the next score, which is Dark Gregor's PC Mark 10 Express, 8-core PC Mark 10 Express top score, and actually world record for PC Mark 10 Express as well, using an 11900K doing 6.6 gigahertz. And so PC Mark 10 is like an office benchmark, is my understanding. And for some reason, is that a thing? Do people run 7000 series cards for this specifically? No, RX 580. Is this like, does this favor AMD? Apparently it does. That's another RX 580. And a 290X. So apparently this really likes AMD GPUs for some reason. Who knew? Apparently if you're building an office PC, you should put an AMD card in it, even if it's really old. So here we've got a 7970 Matrix in the setup, along with a PCIe SSD, which is the Intel Optane 900P. and that's a 280 gig one. And the thing is, like, the reason why you need such a crazy fast SSD with like Optane memory in it is because this is a Office benchmark, so it tests things like I'm assuming file copying and opening files and open like basically it tests sort of like storage performance as well as CPU CPU performance for some reason, to the point that you need a 6.6 gigahertz 11900K to take the record. Seems to favor memory latency over memory bandwidth, as that's a Gear 1 memory overclock over there at 3866 12 11 11 1T command rate, dual rank memory. So that's interesting. I don't think yeah, well, I don't know, but like dual rank memory it is. Same G skill kit as the 11600K score. And then we have a 7970 with a pretty, well, not a super high core overclock, but a pretty decent one at 1225 on the core and 1650, which is actually stock for the memory on the 7970 Matrix. So yeah, I wish I could tell you more about this. But I've never run PC Mark 10 Express because I don't build Office PCs. Though, anyway, yeah, so, like, the CPU is flying, right? Like, this is still all 8 cores and 8 threads, so evidently it doesn't care about, or it doesn't care for hyperthreading. But it is the world record for PC Mark 10 Express, so, like, just that alone makes it a rather impressive score. And then we do have a rather, strong dual rank Gear 1 memory overclock going on there. But the thing is, like, I just don't know that much about this benchmark. And then the SSD thing, I'm assuming you just kind of stick a fast SSD in there, and that's a big part of the benchmark. You're not allowed to run RAM disks. Like, somebody was going, I'm sure somebody was like, oh, you should just use a RAM disk. You're not allowed to run a RAM disk for this benchmark. Like, that is very much against the rules, which kind of makes sense because, like, that would, well, I guess that would just basically turn it into a CPU and memory benchmark again. So this way, I guess it's a bit kind of an SSD benchmark. You can't overclock SSDs, so I'm. Yeah, well, this is a weird benchmark, but mostly it's a CPU benchmark, right? With the 6.6 gigahertz 11900K at the top of the rankings. Actually, I wonder what the second place score is. A slower 11900K. So yeah, that's very much a CPU benchmark once you have all the necessary hardware for it, I guess. Or is this using like a sensible SSD? Apparently you can use a sensible drive, so I guess it's just a CPU benchmark. Still, world record, so congratulations to Dark Gregor on that. And let's move on to the next score, which is Senz's third place in 18-core Geekbench 3 on the 10980XE at 5.9 gigahertz on a X299 Dark, on liquid nitrogen, of course, and like, the thing is, these chips are just so hard to run. So hard to run. They pull so much power. And the thing is, like, so one thing that tends to happen when running them on LN2, which I'm not sure if that's what this photo is of, but basically they boil the LN2 in the LN, like if you have your LN2 pot properly like frosted over, they boil the liquid nitrogen so quickly that you basically can't pour it in properly because the boiled off nitrogen just like it boils so violently that it kicks up. So you go to pour and it basically spits nitrogen back up out of the LN2 pot because of how much heat these CPUs put out. So that makes these actually really difficult to run. They pull just insane amounts of power. Especially once you're approaching 6 gigahertz. And then 4000, actually 4070 CL12 on the memory, which is really hard to run on the X299 memory controllers, like especially on liquid nitrogen. And there's a lot of motherboards that won't even do for like 4070 CL12 even at ambient on X299. So the X299 Dark is one of the few boards that'll actually do these kinds of memory settings with relative ease. Not really. These memory controllers are horrible, and it's but it is actually possible. Whereas, I've done that. I've done that with my X299 Dark and my 7940X, or close to that. But actually, no, I haven't, because all of my memory sticks require low VTT DDR. But yeah, so that's well, if you have a good, I guess if you have a kit that can do 4000 CL12 with low enough VDIM that you don't need to drop the VTT DDR, that works out just fine. But it is, this is technically doable, these kinds of speeds, but on very few X299 motherboards. Actually, no, I'm pretty sure I did a 4000 CL12 on the Dark with the Corsair memory kit. Yeah, I'd have to go through my videos to figure out if I did that or not, because I've done that. I think I've made attempts at that twice. But yeah, this kind of memory these kinds of memory settings are actually really hard on X299, and the Dark is one of the few boards that actually makes them possible, which of course helps you with the memory subtest in Geekbench 3. And then the CPU score is basically just how far can you clock the core, which 5.9 gigahertz is really fast for an 18-core X299 chip. Basically, up until 5.3 gigahertz, they seem kind of easy to work with, and then you try to go past 5.3 gigahertz, and things get very difficult very fast, because the power consumption the thing to realize with power draw is it's non-linear, it's quadratic, so as you keep adding voltage, the power draw goes up more and more and more every time you increase the voltage by a fixed amount. So yeah, by the time you're at 5.9 gigahertz, and the frequency itself actually increases your power consumption further. So by the time you get to something like 5.9 gigahertz, your power draw is absolutely insane. And honestly, even at 5 gigahertz, these chips are very, very thirsty. So yeah, these are very hard CPUs to run. The memory can also, they have strange cold issues as well with memory overclocking. Very not quite as bad as trying to run Ryzen on liquid nitrogen, but very fiddly. And they have a cold bug, which is actually probably the heat output would be much easier to deal with if you didn't also have to keep the temperature at a very specific level, because these chips generally don't work below minus 110 degrees Celsius. So you don't just get to fill up the LN2 pot with liquid nitrogen and, relax while fiddling with settings. No. You have to sit there and maintain minus 110 degrees Celsius, or potentially even pull the CPU pot lower for the benchmark in order to get to keep the CPU stable. Because yeah, these have a cold bug, which is due to the fully integrated voltage regulator they have. It basically just doesn't work at very low temperatures, and so that makes these chips insanely hard to run, because huge power consumption, nasty, has a cold bug, so you can't just fill up the LN2 pot and call it a day, because the chip will stop running. And then also a very fiddly memory controller, because the other thing is it likes to drop memory channels on reboots, which is one of the X299 Dark actually has LEDs for indicating if all of your memory channels initialized properly, which is super helpful, because the number of times they don't initialize properly is way too often. So yeah, a very impressive score from Sens in Geekbench 3 here, because just these chips are so hard to run. So insanely hard to run. They pull so much power. They're the memory overclocking on them is fiddly. They drop memory channels. Yeah, just very great score from Sens here. Congratulations to him on that. And let's move on to the next score. And man, this video is going to be so long. Seriously, why did they all post these scores in the same week? They could have posted So anyway, now we get into more scores. So now we get into some more GPU scores. So here first we have Shard 00750 3D Mark Vantage performance top score for the HD 6870. So this is run with a 5950X at 5 gigahertz because 3D Mark Vantage loves having a 16-core CPU available. And the 6870 is on liquid nitrogen, doing 1400 megahertz core and 1315 megahertz memory. Actually, 1300 megahertz memory. So I guess GPU's like bugged out or something. Or maybe he just rounded it down for the submission here, so it's 1317 on the memory. Unfortunately, I don't know much about 6000 series and AMD GPUs on LN2. But it is a really big overclock. Like, that's 55% more core clock than stock. And if we compare to other 6870 submissions, that's basically as high, like, that's about as high clocked as they come, right? 1400 core, 1300 memory. The memory really doesn't seem to overclock very well on these cards. Yeah, so, you know, a very impressive core clock on the GPU there from Char. And then 3D Mark Vantage, I mean, it really does love having a 5950X at 5 gigahertz because that really just maximizes the CPU score. The benchmark doesn't know what to do if you have more than 16 threads, so for Vantage, you do need to disable SMT on a 5950X. And then it's not super memory sensitive, but, you know, like memory overclock, like it doesn't hurt to have good memory settings, and so here we see 3800, 14, 13, 13, 21, with a TRC of 29, which I'm pretty sure is getting overridden by the TRP or TRAS, because, yeah. Anyway, command rate 1T, so probably in gear down mode, and a single rank memory, which, again, like this is Vantage. It doesn't care that much about the memory. It cares a little, but not that much. Running on a Gigabyte X570 AORS Master. And yeah, that's 6870 on LN2. Like a lot of these older AMD GPUs, like I've not run the 6000 series specifically, but I have run 5000 series, and honestly, they're really well behaved on liquid nitrogen. There's no weird like, or well, you'll basically have like a cold bug and then you just kind of sit there, or yeah. It's not like modern GPUs where you have all kinds of weird problems because of power management or whatever. So yeah, though 6000 series is old enough that I don't think you can mod memory timings on these, or at least I don't know how to mod memory timings on these. I wonder if anybody's figured out that out, because that might be like a really big like boost, especially on cards where, you know, everybody seems to be hitting the same kind of memory frequency wall. If you could hit the same memory frequency but with better timings than everybody else, then that would certainly not hurt your scores, would it? But yeah, so a great score from Char on the HD 6870 here, and congratulations to him on that. And let's move on to the next score, which is Burner's Cinebench R20 on the 10600K. So this is the fastest Cinebench R20 score on a 10600K, mostly because 10600Ks aren't cool, as you can see from the submissions. Which is a bit of a shame, because like the 10600K is actually probably one of the more interesting CPUs that Intel has recently produced. I mean, it's basically an 8086, like an 8600K. I mean, 8700K. But at least it's soldered, which makes it a lot easier to work with on liquid nitrogen than an actual 8700K, because on an 8700K you have to deal with like replacing the thermal paste. And then you still have to deal with the fact that even the thermal paste designed for running on LN2 don't always, you know, survive full pot for that long. So, yeah, whereas with soldered CPUs like the 10600K, you don't really have to deal with that. So, yeah, so fastest 10600K Cinebench R20, which unfortunately, because people on HWbot don't like benching 10600Ks for some reason, which I really think it's a shame. Like, this is actually one of, like, the 11600K is unfortunately in the same situation. Like, the 11600K has one benchmark where it's kind of competitive, and that's Y-Cruncher, and then everything else you would realistically just use a 5600X instead. But as a daily CPU, the 10600K is actually, like, like it's a cool CPU, especially considering for like the price it's at. So, um, yeah, it's kind of kind of sad that it's underrepresented on HWbot the way it is. Considering that it's sort of like right now it's a better deal than like a Ryzen 5 3600 probably. I haven't checked prices in a while, but like 10600Ks aren't that expensive. And they're and they're reasonably fast. Like, so yeah. Anyway, this is on a Z590 Aorus Tachyon, running actually really casual memory settings. The thing is, I mean, if we check the comment down here, just a test of daily CPU with 5 liters. So literally, is he seriously dailying a 10600K? That actually wouldn't surprise me. Like, I for the longest time daily to 11, like a 7 Ryzen 7 1700 with a half dead memory controller. So yeah, somebody on like a HWbot user dailying a way slower CPU than what they regularly bench is actually totally like, yep, that makes sense because you need the good CPUs for the benchmarks. And the slow CPU goes into your daily system. You won't notice the difference anyway. Yeah, 10600K, 6.6 gigahertz. Which unfortunately, we don't know how that compares, though. I think this is somewhat slower if you compare it to like 8700Ks, which sort of makes sense because 8700Ks were the top bin for the 8000 series, whereas 10600Ks are basically binning rejects. And also, this was just 5 liters of LN2, so Burner probably didn't put that much time into really dialing in the CPU. 1.75 volts, which is pretty high. Then again, we don't know how much VDROOP is on that. And the memory settings, I mean, it's Cinebench. Like, that is a very, that's basically daily memory settings right there. And then you are running Cinebench, it doesn't really matter that much. Yeah, I wanted to include this score because it's just, cool to finally see somebody push a 10600K on LN2. Because, yeah, Burner is literally the first person to run one of these 10600Ks on LN2. And, that's the thing is like overclock all the things, not just the things that get world records, all the things, including 10600Ks. 10600Ks deserve to be run on LN2 as well, especially since they're less work to run than 8700Ks. Anyway, let's move on to the next score, which is Super Pato Donaldo's Y-Cruncher Pi 1 billion on the 7900X. Wait a minute, why is this in this section of the roundup instead of earlier in the roundup? Doesn't matter. 10-core 7900X. It's a 10-core CPU with a quad-channel memory controller, so naturally it's extremely good for Y-Cruncher Pi 1 billion because Y-Cruncher loves memory bandwidth, especially if you have 10 cores. Like, the more cores you have, the more memory bandwidth you need. And of course, the 7900X AVX has AVX 512 support, running on an X299 OC formula, 3800 CL16 on the memory. So basically daily, like very dailyable memory settings right there. Yeah, extremely dailyable memory settings. A 2T command rate of all things. And the reason why you would be at these extremely dailyable memory settings is this is Y-Cruncher. It does not tolerate instability to the same level that a lot of other benchmarks do. And this is apparently on phase change, and hitting 4.3 gigahertz, and also apparently hitting 37 degrees Celsius load. I think the idea here was, I'm going to use my phase change to run higher clocks than everybody else, and then the phase change can't put up with the heat output of the CPU. Because I ran a 7820X in Y-Cruncher, it pulled... And that's an 8-core. It pulled at, I think, 4.3-ish gigahertz. Yeah, I think it was 4.3 gigahertz. It pulled like 370 watts of power. Which, if you have a 10-core, you're looking at well over 400 watts of power drop. So, yeah. So that's why we're not seeing a super high CPU. I'm guessing the reason the CPU clock is like relatively low, considering the cooling being used, is that that phase change is probably not designed for 4 to 500 watt. Like honestly, this would probably hit 600 watts if you pushed it hard enough. Like that phase change probably just can't deal with that level of heat output. What's the idle temperature? Max temp 37. We don't have an idle temp readout, so yeah, it's going to be below 0. Like, there's no way you're running 37 degrees load without being below 0 for idle. Like, Y-Cruncher on a water cooling loop is hitting over 100. Easy. On a chiller, it's hitting 100. Like, this benchmark just redefines CPU power consumption on anything that has enough memory channels to feed the number of cores and has AVX 512 acceleration. But yeah, third place on, like a really, really hard benchmark. And also, like, you can see, not a big gap in the actual score from a, like, 4.3 gigahertz 7900X to a 5 gigahertz 10900X. And then Splave is in first place at 4.7 gigahertz because this is really about your memory. Like, the benchmark is so memory limited that running 5 gigahertz, like, you're just going to be, like, yeah, you're going to be running 5 gigahertz, but you're going to be wasting a lot of your clock cycles, not actually doing work for the benchmark, if your memory settings aren't good enough. And so yeah, that's more Y-Cruncher. Congratulations to Super Pato Donaldo on like, it doesn't sound very impressive, but like, this is a hard benchmark to run. Like, it really, like, this is the benchmark that makes your CPU overclock look bad. Like, when actually it is, like, this is hard. This is really hard. Also, on a lot of motherboards, it ends up tripping VRM power throttling, which is another very real issue with this benchmark. Like, I tried to run it on one motherboard, and I couldn't, like, the CPU wouldn't stop power throttling no matter what I did. So, yeah, just Y-Cruncher things. So congratulations to Super on the Y-Cruncher third place with the 7900X, because it's a very tough benchmark. Let's move on to the next score, which is Gypsy's 3D Mark Vantage performance on the HD 7770 on phase change. And the card is running 1500 core, 1565 on the memory, which is really high for an HD 7770. These cards are really fun to overclock. Unfortunately, they're also they're expensive on eBay. Like, these are old, slow GPUs. They require a 6-pin power connector, and yet for some reason on eBay, people want like 30, 40, 50 quid for them. And I'm serious, like, there's 77770s on eBay for 50 freaking quid. Like, what? Why? It's like, you can get 7970s for that much, or at least you used to be able to get 7970s for that much. Yeah, but these are really fun to overclock if they weren't so damn expensive. And a big part of that, to me, a big part of that is, like, they don't pull a lot of power. They clock insanely high, and they're actually kind of have some interesting voltage behavior. So they scale with, they have an interesting relationship between, like, core voltage, memory controller voltage, and memory clock and core clock, where basically if you raise core voltage without touching the memory controller voltage, you actually lose memory clock. So these cards are sort of fiddly to work with. So you really need a memory control, like you need to volt mod the memory controller rail. Depending on what memory chips you might have, you might benefit from a memory voltage mod as well. There's also a 0.95 volts rail, which could help if you were running like liquid nitrogen or something, but I don't think anybody has done that. I think people have only ever run these on phase change, and running them on LN2 would actually be extremely awkward, because getting an LN2 pot on one of these cards is not easy. It looks like this person figured out how to do it. I wonder if they just sat the LN2 pot on top of the card, because that's probably the easiest way to do it, because the mounting hole spacing on these is really, really close together. Though there are some older LN2 pots that actually fit that hole spacing, so maybe it might be just one of those. Yeah, fiddly cards to run, and also 1500 core is just, like, that's, I believe, the fastest clocked. Actually, no, so 1500, but 1565 on the memory. So yeah, that's kind of the trading core clock for memory clock situation there. And the funny thing is, these cards end up getting very CPU, like very memory bottlenecked, if you don't like as you raise the core clock, because the memory controller is only 128 bits wide. Um, and so, once you start hitting like over 1300 or 1400 memory core clock, the memory starts being a real very big bottleneck. And of course, these are 7000 series cards, so you can mess around with modding the memory timings. So that's cool. So yeah, these are really like, well, if they were cheaper, they'd be really, really fun. They unfortunately aren't. I mean, they're still fun. They're just not cheap, which is kind of unfortunate because they are kind of like they are actually really slow GPUs, right? Like 21,000 points in 3D Mark Vantage at 1500 megahertz core. Not great. Gypsy's score is being helped along quite significantly by the 5950X at 4.65 gigahertz, producing a 117,000 point CPU score, but I'm pretty sure 12 was running a 7900X, because, oh no, this was a 6900K, so this was before he had the 7900X. So, yeah, that actually, let's see, how much GPU score is Gypsy getting? 12 is actually getting a slightly higher GPU score. Also for Vantage, actually no, Vantage I think is just outside of being able to do that. But yeah, so cool score from Gypsy on the 7770 here. These are really fun cards, and that's one of the main reasons why, of course, this got included in this roundup. I think these are awesome. It's just a real shame that they're so damn expensive. Other fun AMD GPUs are like, there's also very simple to vault mod. That's kind of nice. But other fun GPUs would be like the 7790, which is actually more interesting because those clock even higher, in my experience. They don't have the weird memory controller to core voltage behavior, where the memory controller gets worse as you raise core voltage if you don't raise memory controller voltage, or at least I've not run into that with 7790s myself. And you can still mod memory timings. Like basically 7000 series AMD GPUs are cool, and everything after Polaris is terrible from an overclocking perspective. And I'm mostly serious about that. So yeah, congratulations to Gypsy on, really pushing the 7770 to its limits there. He had a few other scores, but I didn't include them because we've got way too many damn scores. Actually, speaking of a few other scores, here's one of them. 1445 core and 1550 on the memory. 3D Mark 11 performance is probably, for a lot of these older cards, this is actually the heaviest benchmark you can run, interestingly enough. Like, this is super hard on a lot of older GPUs. And yeah, the 5950X is back. Helping the GPU along quite a bit. 12 in second place, of course, because 6900K along with the card on phase change. And 12 really managed to push the core clock on his card a lot higher, which is interesting. Apparently, Gypsy's card just didn't scale very, very far, like with extra core voltage past a certain point, even at minus 50 degrees Celsius on the phase change. So that's probably just a silicon quality thing, though. Because I don't think 12... Actually, 12 might be on a... Oh, 12's at minus 90. Oh, wait, no. I think that's for his CPU. I'm very... 6900K. No, he's not running that on the CPU. If I remember correctly, his Cascade's not strong enough for the CPU. Also, that's just for... Actually, wait, no. Cascade, single stage. Oh, interesting. Oh, right, because 6000... Broadwell's terrible. I forgot about that. I'm like, 4.7's not that high. That's because I was thinking Haswell E overclocking, not Broadwell E overclocking. Broadwell E clocks like 300 megahertz worse than Haswell E. Actually, more like 400. It's really bad. Like, Broadwell E is terrible. They did fix the memory controller, but everything else got worse. Yeah, so Gypsy also took first place in 3D Mark 11, though here I'd say it's almost entirely down to that 5950X, isn't it? Yeah, the much higher combined score. Yeah, slightly behind on GPU, much higher combined, much higher physics. That 5950X is extremely helpful for some of these, like, because the thing is, for HWbot, it's the overall score that counts, not just the GPU score. There are some benchmarks, like, say, Unigine Heaven, which is a pure GPU benchmark, so if you want to run something like that on older GPUs, There's Unigine Heaven. And then for modern GPUs with ray tracing, we've got Port Royal or Unigine Superposition. But for something like 3D Mark 11, it's a combined benchmark. You do also need a fast CPU. But I kind of like the fact that you can do this with, like get a 770 and then rerun it with a 5950X, because it allows people to revisit these old, slow graphics cards with ever faster CPUs. And in the process, maybe like, going back and now it's like, oh, well, now we know how to, like, I don't know if at the time that 12 did the 7770, I don't think memory timing modding was very much of a thing back then yet. When's this from? Actually, 27, no, so this would have been with memory timing mods, I think. Maybe? I'm not sure. But yeah, so also as time goes on, the cards get steadily cheaper, or at least they should. For some reason, 770s don't seem to be subject to that, but yeah, so you can go steadily more and more unreasonable on the level of modification you're willing to do to the cards. Though these are unfortunately kind of awkward with the mounting hardware compared to a lot of other GPUs that you could get from like the 7000 series, because these are really small cards with really small cores, and so the whole spacing is really close together. Still, congrats to Gypsy on using a 5950X to drag a 7770 into first place, but that 770 is still going very fast by 7770 standards. And I've said the word 70 too many times now. Let's move on to the next score, which is Salty Croissant's 3D Mark Firestrike Extreme on a GTX 690. Yep, on chilled water cooling, which is what Salty Croissant does. Also, all of the RGB. Minus 13 degrees Celsius on the water, apparently. Minus 8. I guess that's idle core temperature, and then minus 13 on the water. 1332 core, 1863 memory, which honestly for 600 series cards is low. That kind of core clock. But then if you look at the rest of the GTX 690 rankings, oh wait, there's somebody somehow got 1500. So most of these are like really low clock speeds. And this one has like, what is going on there? The score's not that great either, so I really do wonder what's going on here. 1075. Oh, so he's just not reporting it correctly, because 1075 is... So I don't know what's going on with that, but it's not that. It's not a 1536, unless his BIOS is like super weird. Normally the boost algorithm for Kepler cards will give you you'll get like 100-ish megahertz more. So you'll get like 1200 in GPU Z readout, 1332 on the actual core clock. The thing is, GTX 690s are unfortunately limited to only reference NVIDIA PCB, only the reference NVIDIA PCB. And dual-core NVIDIA cards tend to have trash for power delivery. Now, the 690 isn't quite so bad as, say, the GTX 590, which is truly horrendous, because the GTX 590 VRM is just grossly underpowered for what it has to deal with. None of these really here's the thing, GTX 680s should very easily be hitting 1300 to 1400 core. And Salty Croissant, he does, did he mod this card at all? Actually, you can get software voltage control for these. So I can't imagine that he didn't have core voltage control. No comment. I think he was at 1.4 volts. Because yeah, you can definitely get software voltage control for these cards. But yeah, so 1332 on chilled water cooling with extra core voltage is not impressive by 600 series standards. So either he got really, really unlucky with the silicon quality here, or, if we look at the other 690 scores, 690s have some kind of power delivery issue, because they all clock like trash. Unless some people are underreporting their clock speeds. Because that's the issue, is some people they report their clock speed from GPU Z instead of the boost clock. So what's this one? Oh, so we just have no idea what this was at, because this isn't reading out anything. So that's great. 1293. So I'm assuming that's boost in that case. Anyway, I do have a 690 actually. In fact, I have multiple 690s. Two of them are dead and one of them is working. I got the dead ones showed up dead. Okay? I didn't break them. They were dead when I got them. And okay, so this one's actually is probably clocking slightly higher as GPU's is reporting 1220, so the boost clock would probably be a bit higher, though this one's still on air cooling, whereas Salty's is on chilled water cooling. So I do have a 690, so I do plan to mess around with that. Maybe probably hook it up to the oscilloscope. I can't imagine that having the VRM like sideways relative to the thing it's actually powering is particularly ideal for power delivery. Your power plane is more of a power strip with this kind of VRM layout. Which, fun fact, reference GTX 680s use the same VRM layout. Though those don't tend to clock terribly. Maybe NVIDIA just binned the cores on these cards for like super low power, like super high power efficiency and consequently terrible clocks, like voltage scaling. That wouldn't necessarily surprise me too much if it was that rather than the actual power delivery. Like that the silicon on these is just awful for overclocking. I guess we'll find out if I ever manage to. Well, we'll see what I can do with the working 690 I have, and then if I revive the other ones, then we'll have more comparison points. Anyway, next score we've got Kepi's 1475's Unigine Heaven Extreme score, and he beat my score, which is why he gets into the roundup. So, I really pushed my GTX 590 hard. It's like super heavily modified, as you can see. And the thing is, I was trying to run it on an 8086K, so it was running at PCIe X4 because the gene, like if you can't really tell, but basically I'm in the chipset PCIe slot. I'm not in the CPU PCIe slot, so that's probably screwing me over. Also, Unigine Heaven is one of those benchmarks where you can kind of do a few things to get better GPU performance. And well, you know, Kepi's on Windows 7 here. So is 765 on the GPU core, lower memory clock, beating my score by 50 points. I need to go fix like I need to do something about that is basically what I'm seeing here is like I need to rerun my GTX 590 on a proper CPU like a Ryzen 5 3600. Which actually, this is really cool about the Ryzens. They actually have good compatibility with a lot of the old dual GPU cards. The Intel side of things is a horrible mess. Like, there are so many motherboards where if you plug a GTX 590 into the like CPU slots, it just will not post because the motherboard will basically see the PLX chip. Actually, on the GTX 590, it's still an NVIDIA chip. It's not even a PLX chip. It's like an NVIDIA PCIe switch. And so it'll see that NVIDIA chip, it'll go like, the hell is this? And not initialize the GPU. Ryzen boards, for whatever reason, don't have this issue, or at least don't seem to have this issue very often, which makes them pretty cool. So yeah, Ryzen 5 3600, pushing a GTX 590 pretty far. The thing about GTX 590s is they actually have a power limit. There's a bunch of shunt resistors on these cards. Fun fact, this is one of the earliest NVIDIA GPUs to actually feature shunt resistors because this is around the time, I guess, NVIDIA was really pushing the limits of how bad the VRM could be. Very, very bad. Like GTX 590s ended up getting like a software patch to stop them from running Furmark at full speed because the VRM was liable to like die if running Furmark at stock settings, which was just great. Also, if you like this is one of this is one of the top GPUs that you could kill by like overvolting it in software. Like you don't need before NVIDIA basically blocked all access to the VRM on this card. These were super easy to kill, super easy to kill because the VRM on these is garbage. Yeah, an impressive score here from Kepi on just like getting it to run properly. So yeah, I need to rebench my GTX 590. Also, he's got cap mods. That's a lot of cap mods actually. They do help. Because the thing is, like, not only is the VRM underpowered, there's not that much space for filtering on the board either. And these are full-blown JF110s. They pull a lot of power. Actually, fun fact, the stock voltage on a GTX 590 running 3D benchmarks is lower than the stock operating voltage on basically any modern GPU running 3D load. Because the 590, like that core is so power hungry that I believe it runs like 0.89 volts stock. It runs less than a volt. Its idle voltage is actually higher than load voltage because of VDroop. This card is absolutely ludicrous. Like this is basically, this shouldn't exist, and Nvidia built it anyway. And the worst part, like, the thing is, you could actually build a good GTX 590 if Nvidia wasn't like, this is actually, like, compared to some of the cards we have these days, like compared to a RTX 3090 or something, this is actually a very compact GPU. In fact, it's shorter than a lot of dual-core AMD cards from that same time period, because AMD actually sort of went like, look, we're building a dual-core GPU. We need literally to copy-paste 2 sets of power delivery of the same size as if we were doing single cards. Well, NVIDIA, sort of with the GTX 590, they were like, okay, so the GTX 580 is like a 250-watt card. We're going to glue 2 of those together, and then we're going to give them 150 watts of power delivery for each core, which means it is a compact, dual GTX, dual core card, but sacrifices were made for the sake of making it so damn small. And that's why these cards are super easy to break. And yeah. And they also run really hot. Like, the cooling on them isn't great. Like, these cards are just like, if Nvidia had just made them bigger, they could have been so much better. Like, bigger heatsink, triple slot, like bigger VRM, just bigger VRM is number one. Like, would have been a huge improvement for these cards. But the thing is, like, Nvidia was shipping them with a 350 watt stock power limit, so, not much reason. Like, from Nvidia's perspective, it's like overclocking isn't a thing, and they don't officially support it. So the fact that the card can't sustain anything other than stock operation properly doesn't really concern Nvidia very much. Oh, we've got even a shunt mod over there. Yeah, so this thing, like, this is almost like a copy paste of my card, except my card also had volt mods. Like, that yellow wire there, I think, is extra memory voltage, and that white wire sneaking up around the edge is extra core voltage, which is basically a big part of why I can run 810 core instead of just 760. In fact, I think my card's one of the higher clock GTX 590s for Unigine Heaven. But, congratulations to Kepi on figuring out how to actually run the benchmark properly, whereas I just kind of winged it on Z390. Also, this is glitched out. Wait a minute. Am I losing points for that? Okay, no, I'm not. 810. So there's, yeah, oh, I know. Slams has the... Yeah, Asus built a proper GTX 590. Unfortunately, they only made 500 of them. And so getting one of these days, super rare, super expensive, and very likely to not work, because the JF110 core is one of those big chips that likes to thermal cycle itself to death. So that's unless the card went to a collector who just kept it locked in its box and never used it, in which case it's probably fine. But then it's like, why would you take it out of the box to run benchmarks on it, right? When you could just abuse a perfectly good regular GTX 590. Oh yeah, so congratulations to Kepi on, like, really dialing in the benchmark there, because that is actually, well, 765 is that's not exactly a low core clock for a GTX 590, like, judging from these rankings in general. And then SLI, I guess there's also some things you can do to optimize just the SLI operation alone. So yeah, congratulations to Kepi on beating my score. I'm going to have to respond to that eventually. It actually wouldn't be that hard. I just need to pull the GTX 590 out of the drawer and install compatible drivers. I could use the 5950X for this. Not that it makes a difference. Unigine Heaven only needs like a quad-core CPU. I don't think it slows down if you give it too many cores, but it certainly doesn't need more than 4 cores. So, yeah. Anyway, let's move on to the last score of this week's roundup. Man, hour and a half roundup. Well, it's not my fault. People decided to make a lot of cool scores. And last score is Zombie 568, W prime 32M top score for the Intel Celeron G530. Yeah, that's a CPU that exists, and you can overclock it with BCLK, and it's a Sandy bridge, which makes that super difficult because you can, like, 108 BCLK on a Sandy bridge CPU is very hard. W prime is just a CPU, like just a CPU frequency benchmark. There's nothing else to it. So yeah, Zombie here pushed the Celeron G530 from 2.4 gigahertz to not even 2.6, like approaching 2.6 gigahertz. So a literally 8.04% overclock, because that's by how much he raised the BCLK. But like that is actually impressive. The thing is, 8% more BCLK on Sandy Bridge is hard. That is hard to do, because everything in the system tends to get upset when you do that. And this is on phase change, which I believe actually helps with the BCLK margin on these CPUs. So yeah, that's kind of the thing. Like, yeah, hooray Sandy Bridge. Actually, I'm surprised that he's running this on phase. Like, Sandy Bridge tends to have a really warm cold bug. So this is a really, like, it's a G530, and I wonder if he got any other top scores for this. Because this is the first one I picked up on. Flag. Okay, that flag. And only W prime. Interesting. But where was I going with this? Yeah, so this is like this is just a weird score, or like a cool score, because potato, like, this is the kind of CPU that you would use like as a socket protector for your motherboard if you don't have the like plastic socket protector. Like, you'd get something like a Celeron, or I assume you'd get something like a Celeron G530. I can't imagine these things are too expensive. They're 2 cores, 2 threads. Who wants one? Sandy Bridge, old, probably comes from Office PCs. I'm sure you can buy these by the bucket on eBay at this point. So literally, you can buy buckets of socket protectors that look like CPUs. That's what these are. But, also impressive memory settings. But the thing is, why, like, W prime really doesn't care about that. W prime is basically Windows XP. There are some things you can do to your OS install to improve the efficiency of W prime, and then it's just CPU frequency, and that's kind of it. And the memory settings here is actually why I was like, hey, did Zombie actually get any other top scores for the G530? Because those look like memory settings that you'd be running for something like SuperPi or something. Which maybe he got a decent score for that, just not like a top score. Okay, well, not top 10 on 32 million, which, I mean, I guess you wouldn't really want to run that. It takes forever. 1 million, also nowhere to be seen. Okay. I'd like to see him run some other benchmarks with this, assuming that it's stable enough to run them. Because, well, 23 seconds on... Why? W prime is a multi-core benchmark, so it's not that light if your CPU only has 2 cores. So, yeah, cool score from cool score from Zombie 568 here, with the Celeron G530, and that's it for this week's HWbot score roundup. Why are there so many damn scores? Anyway, so yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring score. Teespring store, not score. I've said score too many damn times now. Yeah, Teespring store, where you can pick up shirts, stickers, posters, the usual YouTuber merch. There's a link to that down in the description below. And yeah, if you check out the Patreon or Teespring, it would be much appreciated, as they both help out immensely with running the channel. And that's it for the video. So thank you for watching, and goodbye.